In this video, we're going to try to solve a word problem, and we are instructed to use a matrix to solve. So since it is a word problem, I'm going to start by reading through it. It says I have a pile of 70 coins, nickels, dimes, and quarters. The pile is worth $8.30. I have twice as many dimes as I have quarters. So we have talked about solving word problems previously, and we have mentioned making an items equation and then a value equation. So this first sentence, I have a pile of 70 coins, and I'm going to use N for nickels, D for dimes, Q for quarters. And I know that if I take the number of dimes and nickels and quarters and add them all up, so N plus D plus Q, I'm going to have 70 coins on that pile. And then, so this is our items equation. And then next, we can make a value equation. So for my value equation, I'm using this second sentence. So the pile is worth $8.30. So a nickel I know is worth 5 cents. And I do have to think of this in terms of dollars though. So I'm going to put 0.05 for 5 cents, like $0.05 for the nickel. And then 10 cents for the dime, so that would be 0.10. You can just put 0.1 if you prefer, so 10 cents for the dime. And then 25 cents, so 0.25 for the value of the quarter. And then when I'm including the value of each coin, I get $8.30. So those are the two equations that we typically make when we're setting up a word problem. But this particular word problem, one, it has 3 different variables, which we haven't done before. All these before we just had 2 variables. And 2, it has a third sentence, which gives us another relationship. So it says, I have twice as many dimes as quarters. So I have more dimes, this is more, than the quarters. And specifically, the dimes, which were represented by D, is going to be exactly 2 times the number of quarters, twice as many dimes as quarters. Now, in the matrix setup, the matrix is an organized system where we just use the numbers. So in the matrix setup, we have to have everything organized exactly the same. And I'm going to base that organization off of my first equation. So I have this first equation, it has N, then D, then Q. My second equation is well organized, N, then D, then Q. This last equation is not well organized at all because it does not follow the same pattern. So I'm going to have to get the D and the Q to be on the left-hand side and equal to some constant. And so this feels a little weird to just reorganize, but we're going to match it up so that we can use the matrix to solve. So I'm going to subtract 2Q from both sides. As long as I do the same thing on both sides, that's legitimate algebra. So now I have D minus 2Q. And over here on the right-hand side, 2Q minus 2Q is 0. So that gives me a placeholder on that side. The only thing I'm then missing is the N. All the rest start with N. So I'm going to put 0N at the front. And I can do that because I'm adding 0. So I'm really adding nothing. And so now I have N and then D and then Q in every single equation. So I'm going to organize these into my matrix. My first column's the N, then the D, then the Q, then the constant. And my equations go each one on a row across. So equation 1, where my coefficients are 1, 1, 1, and 70. I can put my bracket on back here. Equation 2, and my coefficients there were 0.05, 0.1, 0.25, and 8.3. And I dropped all the extra zeros that I could there just to simplify. And then my final equation, equation 3, is this one that I reworked. And so my leading coefficient here on the n is 0. And then 1d, negative 2 is on the q, and 0 for the constant. So at this point, I have my matrix. And I'm going to go to my calculator then to get my calculator to do all the work in solving this. So on my calculator, first thing I'm going to do is I'm going to use the second button and this button with the x to the negative 1 to get into the matrix. And I want to input my matrix, so I'm going to go over here to Edit. And I'm going to put this as matrix A, so I'll hit Enter. And it wants to know the size, so I have 3 rows and I have 4 columns. And you can see I can just use the arrow key to get to the next spot, or I can hit enter each time. And then I need to type in my matrix. So 1, 1, 1, and 70. And you might be able to see here that because I'm on the computerized version of my calculator, it kind of gives me a little spreadsheet here, which makes typing a little bit easier than on my handheld, where it just jumps between each entry. But you enter going each row across, so really entering like all of the coefficients from each equation as we go across. And I'm typing enter after each one of those. All right, so I have my entire matrix in. So now I want to get out of the matrix, because you see after I hit enter that last time, it just took me right back to one of the boxes of the matrix. So using second and the mode button allows me to quit. And then I will go second and this x to the negative 1 to get back to matrix. This time I want it to do some math. And I find it easier to arrow up here to find what I need. The option that I need here is letter B, the double REF for reduced row echelon form. So I get that. Then I go back to matrix to get the matrix for it to work on. So that's matrix A, just hit enter. And now I'll hit enter one more time for it to reduce this matrix and give me the answer. So this is my answer matrix. And so I have 1, 0, 0, 22. And et cetera, et cetera. I am going to go back to my PowerPoint slide and write this down so that we can talk about it. So we did the reduced row echelon form, RREF, and that gave us the matrix 1, 0, 0, 22, 0, 1, 0, 32, and 0, 0, 1, 16. Now, the key thing about the matrix is that it keeps the organization. So this is my N, my D, my Q, and my constant. And this is equation 1, equation 2, and equation 3. So if I pull that first equation back out of the answer matrix, it would have 1N plus 0D plus 0Q is equal to 22. And if I simplify that, because where the zeros are, I don't have to write these, and I don't have to write a 1, this literally is telling me that N is 22. So how many nickels do I have? I have 22. So the next equation across, the 1 is with the D. So it's telling me that the D, the 1D, has a constant value of 32. And in the final row across, the 1 is with the Q. So it's telling me 1Q is equal to 16. Now I see a couple really cool things here that match up, that should match up, but it's nice just to see them. I see that the number of dimes at 32 is exactly twice the number of quarters. So that's kind of cool. That's how we set it up, and that held out. I also see that if I add these up, so adding my 1s, 2, 4, and 6 gives me a 0, carry a 1, and then we have 3 plus 3 is 6, plus 1 is 70. There are 70 points. And the hardest one to check would be go back and check the value, that the value of the pile of coins is $8.30, but that would also check out because the matrix truly does solve. And so it took all those equations, all those relationships that we modeled with the equations, and it gave us the three numbers that are going to work for that. And so I didn't have to do algebra by hand to solve the system of equations with three variables, which would have been a lot of algebra. So there are other examples. If you want to see us go through another one, you can watch another video, but this is how I would use the matrix feature on my calculator to solve a system of equations.